Hello, everybody, and welcome to our webinar, Explore the World of Engineering with Federation University. My name is Giuseppe Marino, and I'm a member of our Future Students team at Federation, and it's great to have you joining us here today. So we'll begin, and before we start, I would like to acknowledge the traditional custodians of the lands and waters where Federation University's campuses, centres and field stations are located, and pay our respects to elders, past, present and emerging, and extend our respect to all Aboriginal and Torres Strait Islander and First Nations peoples. So thank you for joining us, whether you're joining us live tonight or watching a recording of this webinar. And before we begin, I'd like to introduce our academic presenters from engineering who will be joining us today and providing a range of exciting information about engineering here at Fed and the opportunities available to work in this exciting field. It's a pleasure to introduce Dr. Ian Tatt, who is a Professor of Civil and Mechanical Engineering and the Head of Engineering at Federation University. Welcome in. And also
Thank you,
Thank you. And also Dr. Manoj Kandelawa, Associate Professor in Mining Engineering at Federation. Welcome, Manoj. Thank you for joining us today.
Thank you.
Thank you. Okay, so we'll get started, and I'll hand over to our academic presenters to have a discussion about some of the courses we offer at Federation. So I'll hand over to you. Thank you.
Thank you, Giuseppe. So as Giuseppe has introduced me before, my name is Ian Tatt. I'm the Head of Engineering at Federation University. I would like to give a brief overview of the courses in engineering that we offer at Federation. Now, Federation University has embarked on a very interesting journey. We have sought to embrace something called a cooperative education model, which actually implements the idea of education by society, for society, and with society. So the aim of why we choose to follow on the path of co-op is to actually bridge the gap that we actually see between academic learning, industry practice, and mainly this is to ensure that our graduates are well prepared to enter the workforce when they graduate. We would also take the feedback from the industry as the students undergo a co-op placement and revise our curricula so that they are fit for purpose and it will always be relevant to the industry that the student will be engaged in the future. Next slide, Giuseppe. So the flagship degree that we offer at engineering is the Bachelor of Engineering Honours. We, of course, still offer other degrees in postgraduate as well, and those information you can find out from our website. For our Bachelor of Engineering Honours, we have 4 majors: Civil Engineering, Electrical Engineering, Mechanical Engineering, and Mining Engineering. The duration to complete this degree is 4 years full-time, or if you're doing it part-time, then it will be dependent on how much time you invest into the degree each semester. The course has 480 credits, and it comprises of core units, which includes 2 capstone projects, major units, depending on which major you are enrolled in, some minor units, which I will go into detail later, some specialized elective units, and also some co-op professional units. The available minors depends on which major that a student is enrolled into the degree. Next slide, Giuseppe. So this is the general course structure of our cooperative engineering degree. As you can see here, in year 1, all majors will undertake the same set of units. These are core units, 7 core units in year 1, in addition to a co-op unit. What is a co-op unit? I will explain later. Starting year 2, depending on the major that a student chooses, they will start to do different subjects. So, for example, a civil engineering major student would do civil engineering subjects. A mining engineering major student would do a mining engineering major subjects. This will go on throughout years 2, 3, and 4. But at the same time, starting years 2, students will start also to do minor units, depending on which major they are doing. In the 3rd year, the students will also do another 2 co-op units, and these are specifically a co-op placement where there are certain requirements that the student need to conform to in order to complete the placement. In the final year, the students would do 2 additional specialized elective units, which are relevant to the major that they choose, in addition to the design units or the research project units, which form the core of the entire degree structure. The details of what the core units are, the major units, minor units, specialized elective units are there in the slide, and I would take any questions during the Q&A if there are any. Next slide, Giuseppe. So this slide shows the available minors that we offer. So as you can see, depending on which major you choose, you are restricted to do only certain minors, and this comes about because of the how relevant each minor is to the major that you choose, and also the prerequisite of certain units that bars a certain major from completing that specific minor. So for example, if we look at mining engineering, a student who majors in mining engineering can do a minor in either renewable energy, AI in engineering, Industry 4.0, electrical power grid, computational engineering, project management, business entrepreneurship, environmental science, civil engineering, software engineering, engineering studies, or statistical data science. And the same concept would apply if you look at other majors, mechanical, electrical, and civil. Next slide, Seppi. Here, in this slide, I would like to just give a little bit more information about the cooperative placement units. The first cooperative placement unit you will see is in the first year. That is mainly a unit where we try to develop you professionally, try to groom you so that you are prepared to undertake the cooperative placement by the time you reach the third year. Now, what the cooperative placement in the third year means is that for an undergraduate degree, which is the Bachelor of Engineering Honors that I introduced, is that it involves 60 days of paid placement, and the placement is done through a competitive recruitment process. What that means is that we have a co-op placement team within Federation University that goes out to source placements from prospective employers. And the available placements would then be advertised to students who are ready to then undertake placements. Then through an application, the student and the employer will, through a recruitment process, assess the student, interview a student before the student start the placement. So any placement that the co-op placement team procure for our discipline must gain approval from a delegate or my delegate or myself to ensure that the placement is suitable for the student to undertake. By suitability here, I mean that the placement has to be cognate and has to be relevant to the student's study before the student can do it, because that's the spirit of co-op that we would like to implement. We would like the student to undertake placement that is relevant to their study so that they are ready to enter the workforce by the time they graduate. Now, during the placement, a student will be supervised by on site by an industry supervisor. The student will also have access to an academic supervisor, and both the industry academic supervisor and will supervise the student collaboratively. And as I said before, we have a co-op placement team who would continue to support the student, not only at the beginning where the student try to find a placement, but also throughout the journey of the student placement with the particular placement provider. Next step, Giuseppe. So I would like to talk a little bit of our student experience. Maybe next step. So in terms of how we deliver our degree, we have a few modes of delivery. First, is the traditional face-to-face delivery. So if you would like to do a major in civil engineering, we run civil engineering at Mount Helen and Gippsland. Electrical engineering, we also run it at Mount Helen and Gippsland. Mechanical and mining engineering, we run it at only our Mount Helen campus. So in a face-to-face delivery, what it means is that it has equivalent of 2 hours lecture and 2 hours of tutorial per unit of study, meaning per subject. Each semester would involve 4 subjects. The lectures, some of them are live, some of them are pre-recorded, so it's asynchronous, but the tutorial has to be done face-to-face. At Federation, we are committed to a consolidated timetable whereby we try to arrange the students' timetable so that they do not need to travel to the campus. Like say, if you are doing 4 units, we try to consolidate it to a maximum of 2 days per week. Now, the expected contact hours, depending on how a subject is run, is about 8 to 16 contact hours per week. If you would like to do mining engineering and you are located far away from Victoria, then you can do it online. So in terms of the content of each unit, most of it are delivered online. That means you are flexible to there is some flexibility afforded to you to access the content of the unit. The lecturer will provide a recording, or there could be live sessions where you can attend if you can. If not, a recording will still be provided for you after the live session. For online, there are certain units that we require the student to attend the lab or practical. That would be scheduled during that one block week of the entire semester, where you would come here at the Mount Helen campus to undertake the necessary labs or practical in order to complete the unit. For electrical engineering, we this year launched a flexible block unit at the Berwick campus. So the block delivery is a little bit different from face-to-face and online. It is still face-to-face, but we do it through a 3-block study session. So each block, you would undertake 2 units over a period of 3 months. So you would have 3 blocks per year, okay, and each block you would do 2 units. The block usually is scheduled in a way that if it is a first year unit, then you would do the block in the first week of each month. So one block would be about 4 days, morning and afternoon intensive, and then you would commence the next block in the first week, in the corresponding week of the following month. And that goes out throughout the year. But we only do this for electrical engineering at Berwick campus. If there are more questions on this, I'll take it during the Q&A session. Next slide, Giuseppe. So what are the types of skills and knowledge that you will gain throughout your degree? Next slide. Here I list a few of the units that we teach. So it's quite obvious if I say a unit in power electronics or power protection, renewable energy, these are relevant to electrical engineering. Units like modeling and simulation, control systems, they are relevant to mechanical engineering. Mine planning and rock mechanics, they are relevant to civil engineering, mining engineering, and structural design and geotechnical engineering will be relevant to civil engineering. The figures that you can see there are some of the work that my students do. So I teach a lot of computer modeling. So modeling and simulation is a subject that I teach to both civil engineering and mechanical engineering students. So in that particular unit, what students do is that they would use computer to model the behavior of real structures. And in the figures, you can see there, some of my students modeled a drone. They modeled the effect of wind or on the buildings, wheelchair, also like a frame of a racing car. And you can also see some of the students undertaking some of the experiments relevant to their course of study in the labs that we have here at Federation University. Next slide, Giuseppe. So some of our student success and career outcomes. So next slide. I would first like to introduce Simon Lee. Simon Lee is a Bachelor of Engineering Honours Electrical that is studying with us. I believe Simon is in his 3rd year already. And Simon actually just completed a co-op placement with AGL Loyang. And I think Simon's experience is quite a meaningful one. At Loyang, he actually have firsthand seen how theory is applied in practice, where he is working with upgrading the instruments, okay, in the power plant at Loyang. Simon, as an engineer, we usually solve problems. So Simon get the opportunity during his co-op placement to actually employ the strategies that he learned, okay, and apply it in the workplace. What makes the experience richer is that actually Simon is working on a real problem. He's interacting with consultants, he's interacting with vendors, and the learning that he gained through the co-op experience is actually meaningful because he can then relate what he learns to the workplace. Apart from applying theory into practice, Simon, I think through his co-op placement also managed to develop himself, how he should communicate to people in the industry. He managed to develop some leadership skills, which I think is very important if a person would like to excel in the industry as he progressed his engineering career. Now, what's most important, I think, for Simon is that throughout his co-op experience, the university has always been supportive of him. Our co-op placement team works very hard to prepare all our students for their co-op placement. We would actually give a lot of help to polish your resume, write your cover letter. We will run mock interviews so that during the recruitment process, you are each student, okay, that are selected for the interview are more prepared when they undertake the real interview with the placement provider. Next slide, Giuseppe. These are some of my current and former students who are already working as an engineer in the industry. Louise is in her third year in mining engineering. She was my student. She's also Manoj's student. She's currently doing her placement at Stowell Gold Mine. Ryan is now a drill engineer at Rio Tinto. Used to be my student and Manoj students as well. Sean was my student. He's now a dam safety engineer at Hydro Tasmania. He did also a placement which our university sourced for him. We don't call it co-op placement a few years back, but it was still through a similar idea that we source placement for a student and support the student throughout his placement so that he would get a meaningful experience out of it. Finally, we have Stuart, who is a graduate from the Bachelor of Engineering Honours in Mechatronics, who is now working in the industry. And I think from the testimonial that all these students provide, I believe that Federation University cares about the student and aims to provide the student a meaningful experience so that when they graduate, they are ready for the workforce. I will hand this back to you now, Giuseppe.
Excellent. That's fantastic. I think that slide there, Ian, just provides such a great overview of the range of roles and the experiences and opportunities that our students and graduates have gone on to. So it's really wonderful to see those real stories, and as you say, the way that we've prepared them for the workforce and given them that incredible head start to their career is just really exciting. But to also see the projects they're working on is really wonderful. So yeah, thank you very much for all the information. That's really, really great to see. Just before we go on to the Q&A, and if you're joining us live, please feel free to post a question in the chat at any stage. But I just wanted to spend a moment talking about the important entry requirements and prerequisites for our engineering courses, and also the process of how to apply. So the best resource for getting the most current entry requirements and details for each course are available on our website. So you can simply go to study.federation.edu.au. In general, for our undergraduate engineering degrees, you'll need to ensure that you have at least a VCE Units 3 and 4 study score of 20 in English. And importantly, you'll also need to have 3 and 4 a study score of at least 20 in one of either maths methods or specialist maths. Now, some of you who are watching this video might not have completed maths to that level. And if that's the case and you've met the English requirement, you can consider something through one of our pathway programs. So as an example, we have a course called Federation Access Studies, or FAST. And within that course, there is a unit called the Introduction to Technical Maths. So that unit would give you the equivalency of the maths methods entry requirement that you need for mathematics to get into that degree. Again, if you don't meet those requirements, for example, maybe you haven't done the English or you're looking at another pathway, the best advice is to contact the university and we'll work one-on-one with you to find an alternative pathway or alternative degree that you can consider. And that way we can sort of guide you towards that process of ultimately getting into your engineering course. So we'll work with you one-on-one to be able to provide that assistance. If you're a Year 12 student who's watching this video, be aware that you will need to apply through the Victorian Tertiary Admission Centre, or VTAC. If you're a non-Year 12 or mature age student, you can apply directly to the university via our website. So all of the course links that are available on that website at the top will have a direct apply now button, so you can begin your application process. And of course, if you do have any questions throughout the application process in applying for your engineering degree, you're welcome to get in touch with us at any stage, and we can provide you with some more guidance. So as I said, all those details are available on our website. So we've come to the Q&A part of the presentation. So if anybody joining us live has got a question they'd like to post in the chat, please feel free to do so. But just while we're waiting for any questions, I might just go back to Ian and Manoj just with a couple of questions that we received before the event. One of the main questions we often get from prospective students is, what inspired you to become an engineer and work in this field? And what do you find most rewarding about it? So Manoj, perhaps particularly with your background in mining engineering, I might start with you. What sort of inspired you and what excites you about the rewards in this field?
Okay, so if we talk about mining, just wherever you are sitting or wherever you are, just if you look around wherever you are, just you will find that most of the things we get just because of agriculture or because of mining. So just anything, whether it is laptop is there, mobile is there, or anything is there, just because of mining, that is possible. So because mining is very fascinating, so it can say when I was a student, can say it also used to can say fascinate me as well. And now these days you can say, of course, we have different type of mines. Even earlier you can say very traditional type of mines were there. Now these days you can say even remote control, you can say automation, AI, all these things we are using, and we are also delivering such type of knowledge to our student as well. So which is you can say, and that also excites me as well. Thank you.
Yeah, there's so much innovation in the space. So yeah, I can imagine it's constantly changing as well, which is
Yep.
exciting too. Yeah. Ian, what about yourself? What's been your journey and what inspires you and excites you about the field of engineering?
For myself, Giuseppe, I always see myself as a problem solver. In terms of how engineering fits there, actually, if you are an engineer, you're actually a person who solves problems. I think engineering is a good degree. It really opens your mind to actually think out of the box and apply whatever you learn. It also helps you to, or it actually gives you the foundation to easily learn new things so that you can apply what you learn to solve the problems. That's what I believe an engineer is. So I like it because it's a very versatile degree. It has a lot of, I think, career prospects. So if you see from me, I'm trained a mechanical engineer, but I'm able to teach myself things like that are relevant to civil engineering, such that I'm also able to do some projects relevant to civil engineering, for example.
Yeah, that's excellent. That's another question we've also received in the past has been around, I guess, the current challenges that are being faced. Of course, engineering is such a broad sector with so many different disciplines, but I guess with the advancements in technology, but also environmental concerns that, of course, the world is grappling with, what do you see as some of the biggest challenges and the biggest opportunities available for engineers currently?
If we look at are we talking about Australia or are we talking about the world?
Let's look at the world to start with. How about,
Okay.
yeah.
So if you talk about the world, I think at the moment we face a lot of challenge. I think the number of resources we have in the world is finite, and the population actually is continuing to grow. So we have to learn how to optimally use our resources as our population increase. Now, to actually solve this problem require a lot of skill, and engineers are actually the ones that are able to solve this kind of problem because we come up with solutions. We use technology to make our life better. Okay, and I know that's from a broad sense, but if you try to narrow it down, let's say if we start to look at energy. We know that our fossil fuels are depleting. They would not last forever. And of course, now I think engineers are starting to look into renewable energy. And of course, To do that, you require novel solutions. You require new ways of tapping into that renewable energy source that you have. Even when you are able to tap to the renewable energy resource that you have, how are you going to deliver it to the end user? Again, that requires a lot of engineering solutions. The wiring from the source of the renewable energy to the houses would require expertise in electrical engineering. To build the infrastructure to carry the energy from its source to the housing, to the end user, would require a lot of construction. You need civil engineers. To maintain all this infrastructure, you need mechanical engineers. And of course, to build all this, you need mining engineers to get you the materials in order to build all this infrastructure. So that, in a nutshell, is why we require engineers.
Oh, it's a great answer, and I think well, it sort of builds on what Manoj was saying earlier. All the materials required for every aspect of what we do in life, and I think it's very difficult to look at any aspect of the world and where we live in that isn't impacted or affected by engineering or has some sort of role that engineers play. So, yeah, I agree. It's such a fascinating area. Just checking if there's any other questions in the chat. So if there's anybody still online who would like to post a question in the chat, please feel free to do so. But just before we wrap up, I'd like to also just post some additional information about how you can learn more about Federation University and also get some assistance when you require it. So if you'd like to learn more, I mentioned the website earlier. You can jump online for all the information you need about our course offerings, events that are coming up, all the details you need. You can also call us. So if you'd like to speak to us one-on-one, you can dial free call 1-800-FED-UNI or 1-800-333-864. We have an email address there for inquiries, so you can email future students at federation.edu.au if you prefer to do that in writing. And one of the best ways to see the university for yourself, have a discussion with amazing staff like Ian and Manoj, and speak to our students, look at the projects they're doing, and get a really great understanding of the study environment at Federation, is to visit us on Open Day. Open Days happen every year in August at each of our campuses, and it's a wonderful opportunity to experience everything that we have to offer. And as I said, very importantly, to speak to the people who you'll be either learning with or learning from in terms of our academics, their staff. So it's a really great opportunity. So if you can jump onto federation.edu.au/Open Day to learn more. That brings us to the half-hour mark and the end of our webinar. I'd like to pass on a huge thanks to Ian and Manoj for your presentations today and for being part of this session. And we look forward to hopefully seeing all of you joining us in the future, studying engineering at Federation University. Thanks very much.